This is Algebra 2, still in prerequisite skills, and this is our third video on factoring. The first two videos showed you how to factor each of the different types. This video is a how to factor guideline, so it tells you what to look for, and then just a bunch of examples that have a variety of different ways of how to factor in there. So, how to factor guidelines. The first thing you want to do is you always look for a GCF. If there is a GCF or a greatest common factor, you must take it out. Okay? That's the very first thing you do, no matter what. The second thing you do is you determine how many terms the remaining polynomial has. So if it has 2 terms, you're going to see if you can do difference of squares, sum of cubes, or difference of cubes. If you can't do one of those 3, then it's factored as far as it can be. If you have 3 terms left over, try to break it down into 2 binomials. Always make sure you are checking these to make sure you factored it down correctly. Okay? And you can factor that down by kind of doing the guessing and checking through number sense. You can do it through grouping. You can also do it through the factox. It's whichever method makes the most sense to you. Just make sure you check it at the end. And then if you are left with 4 or more terms, you're going to try grouping. All right? So we're going to go through and do these examples using this guideline to help us. So the first example is c squared minus 9. So I'm looking for a GCF. C squared and 9, they have nothing in common, so there is no GCF. So I determine how many terms. We've got 2 terms. So we see if it's a difference of squares, sum of cubes, or difference of cubes. C squared and 9 are both perfect squares, so it's a difference of squares. C squared is a perfect square of c. 9 is a perfect square of 3. You make one minus, you make one plus. There, we factored it. That difference of squares comes up a ton, and so it's going to be beneficial for you to become quick at seeing and identifying those. Second example, x cubed minus 8. So first I look for a GCF. X cubed and 8, they do not have anything in common, so there is not one. Then I go, okay, this is 2 terms. It is a difference of cubes. So we'll factor it out using the difference of cubes formula. X cubed is a perfect cube of x. 8 is a perfect cube of 2, so we'd start with x minus 2. Then we have a squared, so we'd have x squared plus a times b, 2x plus b squared, 2 squared is 4. Hopefully you wrote that formula down in your notes the other day and you were able to just look at that and follow along. Next up, a cubed minus 4a squared plus 3a minus 12. First I look for a GCF. Between all 4 of those, there is not a common term. So then I look and I see, okay, this has 4 or more terms, so I'm going to try grouping. So I'm going to try to group my first 2 terms together and my last 2. There's a plus in between, so we're good. The first 2 terms, a cubed and 4a squared, have a GCF of a squared, so I'm going to take that out. And I will be left with a minus 4. Plus, the second term, 3a and 12, has a GCF of 3. So if I take a 3 out, I am left with a minus 4. So now we have a squared times the quantity a minus 4 plus 3 times the quantity a minus 4. A minus 4s are now in common, so we can take that out, and we are left with a squared plus 3. So they're refactored. Okay, and once again, you can go through and check to make sure that you have done these correctly, and I'm going to do that at the very end of each slide. Okay, next one, 3z squared plus 24z plus 45. So first we look for a GCF. 3z squared, 24z, and 45 have a greatest common factor of 3. So we're going to take that 3 out. When we take the 3 out, we are left with z squared plus 8z plus 15. Now, inside the parentheses, we have a trinomial. So we are going to try to break that down up into 2 binomials. your first term here to get z squared has to be z times z. And this has a coefficient of 1, so we can just look at the factors of 15, which are 1 and 15 and 3 times 5, and find any that add to give us 8. Well, 3 and 5 add to give us 8, so we would say z plus 3, z plus 5. So they're refactored. Now, I do want you to make sure that you go through and always check your solutions, especially until you get better at these. So we'll do one slide at a time for checking. Z minus 3 times c plus 3. When we distribute, c times c is c squared. C times 3 is plus 3c. Negative 3 times 3 is minus 3c. Negative 3 times 9 is minus 9. 3c minus 3c cancel, and we're left with c squared minus 9, which is what we started with. Okay, a minus 4 times a squared plus 3. A times a squared is a cubed. A times 3 is plus 3a. Negative 4 times a is, negative 4 times a squared is negative 4a squared, and negative 4 times 3 is minus 12. These two here are just in the wrong order. So a cubed minus 4a squared plus 3a minus 12, it's all there, so that's correct. All right, here x times x squared is x cubed. X times 2x is plus 2x squared. X times 4 is plus 4x. Negative 2 times x squared is negative 2x squared. Let me get that line out of there. There we go. Is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times 4 is negative 8. These middles cancel, and we're left with x cubed minus 8, which is what we started with. Last but not least, 3, and then in parentheses, z times z is z squared. Z times 5 is plus 5z. 3 times z is plus 3z. 3 times 5 is plus 15. These middle two can combine, so we'll have 3 times z squared plus 8z plus 15. And then the 3 distributes through. So we have 3z squared plus 24z plus 45, which is exactly what we started with. Okay, so look, we factored all 4 of those, we factored them, and then we went through and checked them by distributing it back out, and we got the same thing, so we know we factored them correctly. We'll do a few more examples of these. All right, 0.49 minus z squared. So first thing, we want to look for a GCF. There is no GCF here. There are 2 terms. Z squared is definitely a perfect square. 49 is also a perfect square. So this is a difference of squares. 49 is a perfect square of 7, so this would be 0.7. Z squared is a perfect square of z. So 0.7 minus z times 0.7 plus z. And then you should go through, and you can certainly mentally go through mentally check that. All right, a to the 10th minus b to the 8th. No GCFs. So we have to decide, is this are they perfect squares or perfect cubes? Well, a to the 10th is a perfect square. It is a to the 5th times a to the 5th. So it's a perfect square of a to the 5th. B to the 8th is also a perfect square of b to the 4th. It's b to the 4th times b to the 4th. So this would factor down to a to the 5th minus b to the 4th times a to the 5th plus b to the 4th. And that would be factored. All right, next, 8y cubed plus 27. There is no greatest common factor between the two. There are 2 terms, and it is a sum of cubes. So 8y cubed, 8 is a perfect cubed of 2. So this is like a 2y cubed. And 27 is a perfect cubed of 3. So this would factor down to 2y plus 3 times, we have to square the a, so it ends up being 4y squared plus 6y plus your b squared would end up being 9. And once again, that's just following the formula, so hopefully you have that formula down somewhere. Next one, 4a squared minus 100d squared. So GCF. There is a GCF of 4 here, so we're going to first take the 4 out, and then we are left with a squared minus 25d squared. Our remaining, now we have two terms that are both perfect squares, so it's a difference of squares. A squared is a perfect square of a, 25 is a perfect square of 5, and d squared is a perfect square of d. So this factors down to 4 times a minus d times a minus 5d times a plus 5d. All right, next one, 6c squared plus 13c plus 6. GCF, there is none. This is a trinomial, so we're going to try to break it down into its two sets of parentheses. And recall there's many different methods here. Your first and last terms are both 6. So your only factors of 6 are 1 and 6 and 2 and 3. And we need to figure out a combination that would make 13 between these. And some of you might just have good luck just looking at this and seeing. I see that if I try to multiply 1 and 6's together, I'm going to get large numbers. Like 6 times 6 is 36, so it's probably not going to work. And if you do 6 times 1, it's 6. 6 times 1 is 6, and that would only give you 12, not 13. So I'm going to stick and try these last two. So I'm going to make 2c and 3c. And then because there wasn't a GCF here, if my factors are 2 and 3 here, the 2 can't possibly go here with this 2 because then it would make it a GCF. So, and we didn't have one. So since that 2 can't possibly go there, I'm going to put a 3 there and a 2 here. And then we'll just try it and see if this works. 2c and 3c is 6c squared. 2c times 2 is plus 4c. 3 times 3c is plus 9c. 3 times 2 is plus 6. 6c squared plus 13c plus 6, which is exactly what we started with, so that's factored correctly. And last but not least, 7ac squared plus 2bc squared minus 7ad squared minus 2bd squared. So first off, GCF. So when we take a look, there's not a greatest common factor with all those terms. So we are going to group it. So we'll group our first two, and we'll group our last two. We see a minus, so we want to make sure we change it to plus a negative, so that in between our two parentheses, it's addition. In this first parentheses, the greatest common factor is c squared. So we'll take the c squared out, and we are left with 7a plus 2b. Second parentheses here, the greatest common factor is a negative d squared. So we'll take the negative d squared out. We are left with 7a and then plus a 2b. 7a plus 2b is now in common. So we'll take that out, and we are left with then c squared minus d squared. Typically we'd go, oh, we're done. But wait, c squared minus d squared is a binomial. It's two terms, and it is a difference of squares. So we do need to factor that down one more time. And we know difference of squares. C squared is a perfect square of c. D squared is a perfect square of d. So we know it would factor to c minus d times c plus d. All right, now the problems where I really want to make sure that you go through and check are anytime you have a trinomial, you definitely better be checking you did that correct. Sum and difference of squares, or sum and difference of cubes rather, you're following a formula for. As long as you follow the formula for, you should be fine. However, if you are not certain, always go through and check it. And the difference of squares, you should be able to go through and mentally check.